All right, so we have another topic about measurement of matter that tells us the significant figures. So significant figures is also important when it comes to reading measurement. Okay, so you must know this because in significant figures there are different rules or various rules that we must always remember and follow. So you must know this. Significant figures properly report the number of measured. The number of measured is either the object or the substance that we measure. So, and we need to estimate the digits in a measurement. So, there are rules for applying these significant figures in calculations. So, even though you have a given number or given numbers, or if you are given calculations, and if your teacher asks you to use the significant figures, you must follow these rules. Okay, so here are the rules for continuing or counting significant digits. Number one, all non-zero digits and any zeros contained between non-zero digits count. So meaning to say 300042 has 6 significant digits. All of the non-zero are significant. All the zeros in between of the non-zeros are significant as well. Alright? So if it is not in between, let's look at the next rule. Leading zeros don't count. So all the zeros at the first part of a non-zero number, those are not significant figures. So we have 0.000034. We only have two significant digits or figures because 3, 4 are the only significant in this number. All right? And of course, the third one, we have trailing zeros. Trailing zeros count if there is a decimal point. Again, trailing zeros count if there is a decimal point. Let's have an example. 0.0002500. Okay, so the leading zeros do not count, but the trailing zeros after the decimal point are all counted. So 2500 are all significant numbers, or we have significant figures of 4. Alright? So this green part are the 4 significant digits because those are trailing zeros after the decimal point. And then we have trailing zeros may or may not count if there is no decimal point. So we go with the most conservative answer. Example, if we have 19,000 and this has no decimal point, therefore we only have two significant digits because there is no decimal point. All right, but uh, if you point out that this will become a scientific figures, all of the zeros will become significant figures. You need to put decimal point at the end of the zero. It's like in money. All right, for example, you put 190,000 pesos. So all of the zeros after the non-zero digits and before the decimal point, those are significant figures. Okay? And also, remember this, sig figs is a common abbreviation for significant figures. So when you see sig figs, it talks about significant figures. Okay, so here are also additional rules for the significant figures. Number one, zeros in money are significant. Always remember that. So remember, we have here an invisible decimal point in money. So we have 1,000 pesos. That's, of course, for significant figures. Remember, when you add point at the end of every money, right? So meaning to say, the zeros there, or the trailing zeros after a non-zero digit, those are significant figures. Zeros in money are all significant. Next, we have zeros before the decimal point and zeros with the bar. Okay? On top are all significant figures. So we have here 3,000, That's a point. And then we have here 3,000. Actually, the bar is on top of it. Okay. So if the bar is on top of it, therefore that's significant. So we can have four significant figures. Remember, if there is a presence of decimal point after the trailing zeros or a bar on top of it, that's will that will become significant figures. And of course, number three, zeros placed to the right of the decimal point, like what I've said a while ago, and to the right of the non-zero digits are all significant. Like for this one, 0.7070 are all significant. So the numbers after the decimal points are all significant. That's why we have four significant figure here. So the zero between two non-digits and after the decimal point are all significant. So we must able to count them. And of course, we have number four. If a number is greater than 1, then all the zeros to the right of the decimal point are significant. So we have 2.0. Okay, so we have greater than 1. That's 2.0. So we have two significant figures. Okay? Do not forget those rules and apply it when it is needed. So this is another task for you. How many significant figures does each number have? So we have number 1, number 2, number 3, and number 4. You can practice it and exercise. I will give you time to screenshot it. Alright, so we can go to this part when rounding off and significant figures collide. Okay, so here are the examples of rounding off and significant figures combined together. So we have number of significant figures, rounded value, and reasoning. So if given significant figures are 6, 5, 4, 3, 2, 1, then the rounded value, right? So we have this given. Then what are the reasons? Of course, 6 significant figures because 207.518, all digits are significant. Because based on the rules, all non-zero digits and zero between non-zero digits are all significant. That's why we have 6. So let's look at number 5. So we have 207.52. Of course, we need to round off, okay, 1 up to 2 because 8 is greater than 5. So 1 must become 2. We need to add 1 to it. Alright? Very good. And next, we have here number 3. We have 208. Okay, 5 rounds the 7 up to 8. Like this one. From 0.5, since 5 is greater than, of course, 4. So 5 and above, you will add 1 before that number. So we have here two significant figures, 210. Why? Because the trailing zero is not counted, only 2 and 1. Okay? Why is it happen? Because 8 is replaced by a 0 and rounds the 0 up to 1. So here is 0, since 8 is greater than 5. So we need to add 1 to 0. That's why we get 210. And 0 in 210 is not significant. That's why 2 and 1 are the only significant figures. So we have here 2. And when we round it up again, so we only have one significant figure in 200. Why? Because 1 is replaced by a 0 in this case. Alright? So don't you forget that, and don't be confused in those different kinds of situations. Alright? Because on this part, we will use significant figures in computation. So significant figures in addition, subtraction, multiplication, and division. So let's look at this part. Example number 1. In addition and subtraction, remember that the rule is to stack all the numbers with their decimal points aligned. Remember the decimal points aligned. And then limit or round to the answer significant figures to the rightmost column for which all the numbers have significant figures. It can be determined by the lowest significant figures to the right of the decimal point. So we are talking about the final answer. So first, stack up all or align all the decimal points when you are going to add or subtract. So we have this type of numbers. The decimal points are aligned. Then right after that, you just add. Okay? Then you just subtract at the same time. And then you should limit it to this column on the 10th place. Why? Because this part has the lowest significant figure after the decimal point, which is only 1. Okay? Point 2 has one significant figure after the decimal point. So, we must answer this way. In this case, it is in the 10th place. Therefore, we will limit our final answer to the 10th place as well. Is our final answer, therefore, 1459.0? What do you think? The answer is 1459.1 because when we round this off, 0 will become 1 because of 8. Because 8 is greater than 5, so we need to add 1 to 0. So the answer will become 1459.1. Alright? And of course, in this case, when it comes to multiplication and division, it has a different rule. Okay, the rule is to count the number of significant figures in each number being multiplied or divided, and then limit the significant figures in the answer to the lowest count. So you are going to choose which has the lowest significant figures in the equation. So let's have this case. 38.65 times 105.93 is equal to 4,094, 4 million, that's decimal point, 4,094.1945. Okay, so this is 4 significant figures, this is 5 significant figures, and the answer or the product, okay, will become reduced to 4 significant figures because 4, of course, is lower than 5 significant figures. So what are we going to do to the final answer? Let us limit the final answer to 4 significant figures. So the answer will be 4,094. That's all. Alright? Because 4094 are all significant and they are 4 significant digits. So the first digit drop is 1. So we do not round it off. Okay? Or we cannot add 1 to 4 because 1 is lower than 5. Would you forget that? Okay. In addition and subtraction, first line up your decimal points and then choose the lowest significant figures after the decimal point. In multiplication and division, you have to choose which of the dividend or the multiplier has the lowest significant figures, and then you should follow the lowest significant figures in your final answer. Of course, if your teacher allow you to apply rounding off, apply it. Okay? And we have the third one when we are talking about exact numbers. So exact numbers is derived from definitions or by counting numbers of object, which is considered to have an infinite number of significant figures. Example, we have a coin weighs 1.235 grams. Therefore, the weight of 8 coins is 9.88 grams. So like this formula or this equation, 1.23 grams times 8 coins is equal to 9.88 grams. So the answer must be expressed as 9.880 having 4 significant figures. Like this case, why? because here 8 coins is the example of the counting number, meaning to say it's infinite. Okay, so we must limit it into the significant figures of this grams, because here coins is infinite and that is exact number. So we must express it in 4 significant figures. All right, and that is for exact numbers. And lastly, you have to do it by yourself. You need to try this significant figures. Of course, with the computation. Write the answer for each expression using scientific notation with the appropriate number of significant figures. We have number 1, we have number 2, number 3 example, and number 4. Take time to screenshot it. All right, and of course, for the measurement of matter, dosage is very important. So this is how are we going to apply why we need to measure matter, why matter matters when it comes to measurement. Number 1, dosage or dose is the specific amount of medicine that is known to be therapeutic for an ailment in a patient of a certain size. So sometimes you encounter that when you go to the doctor, they will ask you, how old are you? Or is this for an adult or for a child or for an old age, right? So a certain age group has a certain dosage. Okay, so usually it describes by units of mass, typically grams or milligrams, and generally they are equated with the number of capsules or teaspoons to be swallowed or injected. So carefully controlled so that the proper number of pills or spoonful contains the proper dose. You will know what will happen if this is not properly done, right? You will become overdose, and that is very dangerous and very harmful to our health as well. Remember that. So always put this into your mind that a medicine can be more harmful than helpful if it is not taken in the proper dosage. So in dosage, we must be able to bear in mind that effects are dose dependent. Again, effects are dose dependent. So it will become only effective if you take proper dosage, if you take right amount of dosage. All right, so that you will not overuse or abuse the drugs. Okay. Dosage, the size of each dose, meaning to say, determines the strength and the duration of the health benefits of the nutrients and also of the therapeutic effects of the medical treatments. So if you lessen it or decrease or lower the intake, it will not become effective. And also if you overtake it, or you overdose it, of course we will be having side effects. Please remember that. So the route by which a dose is exposed to may affect the outcome, because some medications have different effects depending on whether they are inhaled, ingested, taken transdermally, injected, or inserted. It depends. It has always right amount of dosage is equal to its effectiveness. Right? That's why in dosage calculation, you always have to remember that drug dosage calculations is required. So we don't have to become Dr. Quack Quack by our own. We always have to follow our doctor's prescription. Okay? That's why when you go to different drugstores, they will ask for doctor's prescription, because the right amount of dosage is written there, like how many capsules or how many tablets in a day or in a week for it to become effective. Okay, if not, you're just making your own prescription and it's very dangerous. Okay, don't be a doctor quack quack by your own. So if the physician's order is different from what is available, just remember that. And calculating drugs dosages for humans based on the doses used in animal studies can be based on weight. Example, milligrams, kilograms, that's in another part, not with the tablet, all right? Or surface area like milligrams and meters squared, and also based on weight. It can be either of those units or measurement, right? And for an example, I will give you this scenario. Okay, a physician ordered 100 milligrams of Demerol, and Demerol is available as 50 milligrams per tablet. So, how many tablets should the nurse administer? Of course, we need to look for the number of tablets that nurse should administer. So we are going to count the number of tablets that the nurse should administer to the patient. So of course, let's get first the given. We have 100 milligrams of Demerol, 50 milligrams per tablet, and how many tablets are there? Okay, that we need to administer to the patient. So 100 milligrams times equals 1 tablet over 50 milligrams. Okay, because in 1 tablet, there is 50 milligrams, and we need 100 milligrams of Demerol. So we need, of course, 2 tablets of Demerol so that we can give it to our patient. So based on that scenario, we can give the right amount of dosage to our patients so that it will become effective to their health, or else become overdose or it will not become effective. So that's how measurement in matter is very important. That's how precision and being accurate is very important, because it can harm us or it can help us to, of course, improve our health as well. And example number 2, we have the doctor's order in 1.2 grams of folic acid, and folic acid is available as 800 milligrams per tablet. So how many tablets should be taken? So we are looking for the number of tablets that the nurse should administer again in this case. So again, we will get the given. So 1.2 grams of folic acid, then 800 milligrams per tablet, then how many tablets? Again, just apply the given. 1.2 grams multiplied by 1000 milligrams divided by 1 gram multiplied by 1 tablet divided by 800 milligrams, because in 1 gram there is 1000 milligrams, and in 800 milligrams, of course, there is 1 tablet, like what in our scenario in example number 2. So all we have to do is to cancel out all the same units. So we cancel grams, milligrams, and milligrams until we get tablet. So how much do we need? We only need 1.5 tablets or 1.5 tablets. So that's how to become precise and accurate in giving dosage to our patients, or else we know what will happen. All right. And of course, you need to try this. You need to calculate the dosage. So we have example number 1 again. The physician ordered 20 milligrams of Valium. Valium is available as 10 milligrams per tablet. So how many tablets should the nurse administer? Again, we need to look for how many tablets that we should administer to the patient. Then next, the doctor's order is 1 gram of calcium. So what is on hand is calcium as 500 milligrams per tablet. So how many tablets should be taken? All right, I will give you time to take a picture of it or screenshot it. Right? Are you done? There, do not forget to try this. It is part of your written work number 3. And of course, thank you for listening. If you have any questions, suggestions, or clarifications regarding this topic, do not forget to check out my YouTube channel, my Facebook page. Of course, you can contact me on my Instagram, or you can email me. Right, this is my email address. And of course, thank you for our source, and thank you for Montesilio and Villacorte for the general chemistry book. And that's all for now. This is your teacher, Daryl Del Mundo, and that's our topic for today. Goodbye and have a nice day.